This is a talk about sugar and cancer. And I became interested in sugar when I was in college. Not this kind of sugar. It was the sugar that our biology professors taught us about in the context of the coating of your cells. And maybe you didn't know that your cells are coated with sugar. And I didn't know that either until I took these courses in college. But back then, and this was in, let's just call it the 1980s, people didn't know much about why our cells are coated with sugar. And when I dug through my notes, what I noticed I had written down is that the sugar coating on our cells is like the sugar coating on a peanut M&M. And people thought the sugar coating on our cells was like a protective coating that somehow made our cells stronger or tougher. But we now know, many decades later, that it's much more complicated than that, and that the sugars on our cells are actually very complex. And if you could shrink yourself down to a little miniature airplane and fly right along the surface of your cells, it might look something like this, with geographical features. And now the complex sugars are these trees and bushes, weeping willows that are swaying in the wind and moving with the waves. And when I started thinking about all these complex sugars that are like this foliage on our cells, it became one of the most interesting problems that I encountered as a biologist and also as a chemist. And so now we tend to think about the sugars that are populating the surface of our cells as a language. They have a lot of information stored in their complex structures. But what are they trying to tell us? For example, one thing your sugars are telling us is your blood type. So your blood cells, your red blood cells, are coated with sugars, and the chemical structures of those sugars determine your blood type. So for example, I know that I am blood type O. And how many people are also blood type O? Get your hands up. It's a pretty common one. And so when so few hands go up, either you're not paying attention or you don't know your blood type. And both of those are bad, okay? But for those of you who share the blood type O with me, what this means is that we have this chemical structure on the surface of our blood cells. 3 simple sugars linked together to make a more complex sugar. And that, by definition, is blood type O. Now, how many people are blood type A? Right here. So that means you have an enzyme in your cells that adds one more building block, that red sugar, to build a more complex structure. And how many people are blood type B? Quite a few. You have a slightly different enzyme than the A people, so you build a slightly different structure. And those of you that are AB have the enzyme from your mother, the other enzyme from your father, and now you make both of these structures in roughly equal proportions. And when this was figured out, which is now back in the previous century, this enabled one of the most important medical procedures in the world, which of course is the blood transfusion. And by knowing what your blood type is, we can make sure, if you ever need a transfusion, that your donor has the same blood type so that your body doesn't see foreign sugars, which it wouldn't like and would certainly reject. What else are the sugars on the surface of your cells trying to tell us? Well, those sugars might be telling us that you have cancer. So a few decades ago, correlations began to emerge from the analysis of tumor tissue. And the typical scenario is a patient would have a tumor detected, and the tissue would be removed in a biopsy procedure, and then sent down to a pathology lab where that tissue would be analyzed to look for chemical changes that might inform the oncologist about the best course of treatment. And what was discovered from studies like that is that the sugars have changed when the cell transforms from being healthy to being sick. And those correlations have come up again and again and again. But a big question in the field has been, why? Why do cancers have different sugars? What's the importance of that? Why does it happen? And what can we do about it if it does turn out to be related to the disease process? So let me tell you a little bit about the importance of your immune system in cancer. And this is something that's, I think, in the news a lot these days. You know, people are starting to become familiar with the term cancer immune therapy. And some of you might even know people who are benefiting from these very new ways of treating cancer. What we now know is that your immune cells, which are the white blood cells coursing through your bloodstream, they protect you on a daily basis from things gone bad, including cancer. And so, in this picture, those little green balls are your immune cells, and that big pink cell is a cancer cell. And these immune cells, they go around and they taste all the cells in your body. That's their job. And most of the time, the cells taste okay. But once in a while, a cell might taste bad. Hopefully, that's the cancer cell. And when those immune cells get the bad taste, they launch an all-out strike and they kill those cells. So we know that. We also know that if you can potentiate that tasting, if you can encourage those immune cells to actually take a big old bite out of a cancer cell, you get a better job protecting yourself from cancer every day and maybe even curing a cancer. So, in closing, let me just remind you again. Your cells are coated with sugars. The sugars are telling cells around that cell whether the cell is good or bad. Thank you.